Bismillahirrahmanirrahim. Assalamualaikum everyone. Myself Dr. Mamoona Asir. By profession I am a physiotherapist and today I am going to deliver a lecture on the subject of medical physics. And our topic for the today's discussion and the lecture is magnetic effects of electric current. We have already studied about electric current, how it is produced, how does it work, and what are its principles of working, and how does modalities work with the help of current. So today we are going to discuss about magnetic effects of electric current. What kind of magnetic effects are being produced from electric current? At the time when we were studying about electric current, we did get to know that electric current produce electric field, and in the same way, the way electric field is produced, there is also some sort of magnetic field, and that magnetic field is also produced by current. Now we are clear about a single point, that magnetic field is being produced by electric current. Magnetic fields, how these magnetic fields are being produced from current versus electric in nature, and how does this magnetic field and these magnetic lines of force work, and what are the principles of these magnetic lines. So first of all, we are clear that when electric current is passing through anything or any area or any wire, a magnetic field is found surrounded by that. So now we will move towards the example how we can know that it actually works. For example, the current carrying wire is placed at some surface. Now how we will get to know that magnetic field or magnetic lines or forces are being produced in that region. So the easiest way to get to know and be clear about that is, for example, there is a wire through which current is passing. When the current is passing from negative to positive terminal, what will actually happen, how we will get to know that there are magnetic fields? We will take compass. We know that the compass is an instrument which can detect electric lines of forces. The compass, when we will take our, for example, this is the compass and we are taking it closer towards the magnetic line of forces. We are taking it closer to the electrical wire. So what will happen out here? In that situation, the needle of the compass, for example, this is the compass and it has needles. If it has a needle, if there is the presence of magnetic lines of forces, it will deflect. Now, for example, we are taking this compass closer towards that wire. What will happen in the presence of magnetic field? Magnetic lines of forces, the needle will deflect. And the same way, the needle will actually deflect when the electric lines of forces produces the effect of magnetic lines of forces. So we can say that the current carrying wire can have magnetic lines. There is another way we can detect about it, and for detection of that purpose, what we can do that, for example, we have a wire. For example, this is a wire and this is piece of cardboard. Now this is the piece of cardboard which is passing through the wire. Now when this piece of cardboard is passing through the wire, we have placed some iron fillings over that cardboard. This is the negative terminal, this is the positive terminal. Current carrying wire, cardboard is being placed at the right angle and the iron fillings are placed over it. Now what will happen when we will provide current to that wire? These iron fillings would arrange themselves in concentric lines. They will arrange themselves in concentric lines. And so we will get to know that the magnetic lines of forces are being produced in that region. Now we are clear with another example how it actually works and what basically happens when magnetic lines of force passes through a wire. The concentric as you can see that the concentric circles were being produced on the iron fillings which were dispersed on that cardboard. Now there are two things for identifying that what can be direction of this current, what can be direction of this current, and what can be direction of this magnetic field. So the current direction can actually identify the direction of magnetic field. And how we can get to know about the direction of magnetic field with the help of direction of current? When we are looking towards the current from negative to positive, when the direction of current flow is negative to positive, the circles which are produced, they will form the lines anti-clockwise. So if, for example, these are the lines, we are seeing it from negative to positive, the lines which will be produced, they will be anti-clockwise. Anti-clockwise means they will be moving in this direction. On the same way, if we are looking towards the magnetic field from positive to negative, what will actually happen? They will move in clockwise direction. This is the direction in which clock moves, clock needle moves, and this is the direction in which clock needle does not move. This is the anti-clockwise movement. So this is the side from negative to positive, anti-clockwise, and this is the side from positive to negative, which is clockwise. This is the point to remember, and you people should not forget this point because it is really necessary and important for SCQs and MCQs and finals and in UHS exams and even at your college. So we are clear about the direction of current. Now we want to see that magnetic field of current. Here we just saw the magnetic lines of current. Now how we will get to know about the magnetic fields of current? For having an idea about the magnetic fields of current, I will just draw a coil of wire. In the last examples, we studied the single wire which was not in coil form. But now what we will do, we will draw it in coil form. Coil of wire. This is the negative terminal and this is the positive terminal. Then the current is passing through these coils of wires. The electric lines of forces would be produced at different points. For example, it will be produced at this side, this side, this side, this side, this region. It will be produced at all the way in the coil. So now what will actually happen when these magnetic lines of forces will join together? They will form a magnetic field. And what kind of magnetic field would be developed? There we will draw a line in the center of the coil. This is the N region and this is the south region. So a region is being developed here. The same way a region will also develop here in the other side. The lower side would be considered as the negative side, while the upper side would be considered as the positive side. As the current passes through it, through the coil of the wire, the magnetic lines of force produced, and when these magnetic lines of force join together, they form a magnetic field. And this magnetic field works this way. Now in this magnetic field, if we remove this coil, we will be really clear about magnetic field only. Now at this point we are just removing it for your understanding. just going to redraw this line, and this is clear. Only one line to remove right now. At this point now, I just removed the coil, and this is the way we can see that magnetic lines of force are being produced. One side is being the north, and the other pole which is developed is the south pole. And the same way you can see that the lower side will be considered as a negative one, and the upper side will be considered as the positive one. Now we will get to know the sum of the points, the sum of the principles which are followed in all the magnetic lines of forces. The number one is they are crowded in the center. As you can see, the distance is really small in the central region, but as soon as they are going they are going apart, they will be spreading. Here in the center the distance is small, but in the end side, in the other side, in the far region, they are spreading far away, and they are spreading also in the sides. So the spread is really easy in the sides. The central region will have the less distance and they will be crowded, and in the region they are spreading, they will be having apart distance, and they will not have that much condensed area or crowding in that area when there is ends or the distance is apart in that region. Another thing to remember, the poles are being developed. North pole and south pole. It is really compulsory and it is really important that magnetic field always have polarity, and this polarity is in the form of north and south pole. So north pole and south pole will be developed in that region. If we reverse the direction of current, what will happen? Reversal of direction of magnetic field also happen. For example, this was the negative side and this was the positive side we considered, and this effect was produced. If we just change the side, if we just make it negative side and make it positive side, what will happen? The poles will change and this will change. So it is really easy to identify in that region. And the last thing to remember is the direction of the coil. If you change the direction of the coil, it will also reverse the situation. Then very important thing to remember is Amperes rules. How we can know about the polarity, that which pole is negative or which pole is north and which pole is south. So if the current is flowing from negative to positive side, so on the right hand side we will consider that it is the negative pole. This is the negative side, this is the positive side. Current is flowing from this to this region, so the side towards current is flowing positively, it would be considered as north pole. So this is the Ampere rule which we need to remember, that it will always let us know how we can detect the polarity of the magnetic field. So this is all about today's lecture. If you guys have any query or any questions regarding the topic, you guys can ask me directly and contact me. I will let you know about it. Thank you so much.